Hi sir, I am D Rizwan from ECB section. My roll number is 23401A0495. My topic is design procedure of Laglet compensator in frequency. Subject name is control systems and subject code is 2334405. Procedure for design of Laglet compensator using blood plot. The Laglet compensator is employed only when a large error constant and large bandwidth are required. First design is a lag section and then take alpha is equal to 1 by beta and design a lag section. The step-by-step procedure for the design of lag compensator is given below. There are three steps. Step 1. Determine the open loop gain K of the compensated system to satisfy the specified error requirement. Step 2. Draw the board plot of compensated system. Step 3. From the board plot, determine the gain margin of compensated system. And let pi gc is equal to phase of g of omega at gain crossover frequency. Gamma is equal to phase margin of uncompensated system. Gamma is equal to 180 degrees plus pi gc. If the gain margin is not satisfactory, then compensation is required. Step 4. Though choose a new phase margin. Let gamma 4 is equal to desired phase margin. Gamma n is equal to gamma d plus psi. Psi is equal to 5 degree. Step 5. From the blood plot, determine the new gain crossover frequency, which is the frequency corresponding to phase margin of gamma n. Calculate the beta of law. Step 6. Calculate beta of law compensator. Let AGC is equal to modulus of G of J omega in dB at omega is equal to omega GCL. Step 7. Determine the transfer function of lag section. The zero of the lag compensator is placed at a frequency 1/10 of GCL. Zero of lag compensator ZCL is equal to 1 by T1 is equal to omega GCL divided by 10. Now T1 is equal to 10 by omega GCL. Pole of lag compensator PCL is equal to 1 by beta T1. Transfer function of lag section. G1 of S is equal to S plus 1 by T1 divided by S plus 1 by beta T1 is equal to beta of 1 plus ST1 divided by 1 plus S into beta T1. Step 8. Determine the transfer function of lead section. Take alpha is equal to 1 by beta. From load part, find omega n which is the frequency at which the TB gain is minus 20 log of 1 by root alpha. T2 is equal to 1 by omega m root alpha. Transfer function of lead section G2S is equal to alpha into 1 plus S T2 divided by 1 plus S into alpha T2. Step 9. Determine the transfer function of lead compensator. Transfer function of lag lead compensator GC of S is equal to G1 of S into G2 of S is equal to beta into 1 plus st1 divided by s 1 plus s beta t1 into alpha of 1 plus st2 divided by 1 plus s alpha t2. Since alpha is equal to 1 by beta, then we get gc of s is equal to 1 plus st1 into 1 plus st2 divided by 1 plus s beta t1 into 1 plus s beta t2 alpha t2. Step 10. Determine the open loop transfer function of compensated system. The Lagrange compensator is connected in the series with GFS as shown figure 16.8. Step 11. Draw the blood plot of compensated system and verify whether the specifications are satisfied or not. If the specifications are not satisfied, then choose another choice of alpha such that alpha is less than 1 by beta and repeat steps 8 to 11. Now procedure for design of Lagrange compensator using root locus. The Lagrange compensation is employed to improve both the transient and steady state response of a system. For design a lead section to realize the required dominator closed loop poles. Then determine the error constant of lead compensator system. If it is satisfactory, then only let compensation will be meet the requirement. If the error constant has to be increased, then design a lag section. The step-by-step procedure for the design of laglet compensator is given below. Step 1. Determine the dominant pole SD. SD is equal to 1 by damping ratio plus or minus omega n root of damping ratio whole square minus 1. Step 2. Mark the poles and zeros of open loop transfer function and the dominant pole on the S plane. Let dominant pole be point P. Step 3. Find the angle to be contributed by lead network to make the point P as point on root locus. Pi be the angle where n is an odd integer and so that n 180 degrees is nearest to the difference between angles contributed by poles and zeros. Step 4. Determine the pole and zeros of lead section. Step 5. Determine the transfer function of lead section. Step 6. Determine the open loop gain where k is equal to product of vector lengths of from all poles to S divided by product of vector lengths from all poles to S. Step 7. Determine the velocity error constant of lead compensatory system. Step 8. Determine the parameter beta of lag section. Let kVd is equal to desired velocity error constant. A is equal to factor by which kV is increased. Therefore, A is equal to kVd by kV2. Step 9. Determine the transfer function of lag section. Choose the 0 of lag section as 10% of a second pole of compensated system. Therefore, 0 of lag section ZCL is equal to 0.1 into second pole of G of S. Also, ZCL is equal to minus 1 by T1. Therefore, T1 is equal to minus 1 by ZCL. Now, transfer function of lag section G1 of S is equal to S into 1 by T1 divided by S plus beta 1 by beta T1. Step 10. Determine the transfer function of laglet compensator and compensator system. The transfer function of laglet compensator Gc of S is equal to G1 of S into G2 of S is equal to S by S plus 1 by T1 into S plus 1 by T2 divided by S plus 1 by beta T1 into S plus 1 by alpha T2. The laglet compensator is connected with in series with G of S as shown in figure 6.20. Step 11. Check the velocity error constant of compensator system. If it is satisfactory, then the design is accepted. Otherwise, repeat the design by modifying the locations of poles and zeros of the compensator.